Okay, so here is a section 2.2 polynomial functions of higher order. This video explains the leading coefficient test and finding the zeros of the polynomial function and the intermediate value theorem. What is polynomial function? So here is a definition. The function of the form f of x equals to a sub n x to the n plus a sub n minus 1 x to the n minus 1 plus a sub n minus 2 x to the n minus 2 plus so on plus a sub 2 x squared plus a sub 1 x plus a sub 0, where a sub n minus 1, a sub n minus 2, a sub 2, a sub 1, a sub 0, they are real numbers, and an, which is the leading coefficient, is not equal to 0. So this is called the polynomial function of x with degree n and leading coefficient a sub n. So here are some examples of polynomial function, like a linear function ax plus b, ax squared plus bx plus c, ax cubed plus bx squared plus cx plus d. So if you notice all these examples, the exponents of x's are whole numbers, positive whole numbers. Leading coefficient test for the end behavior of the graph of polynomial function. So here we have polynomial function, and if the degree of polynomial function is n and it is odd, like a 1, 3, 5, 7, and the leading coefficient is negative, then the left hand behavior of this graph would be the graph rises to the left and falls to the right. Okay, if the polynomial function, the degree is still odd, like 1, 3, 5, 7, but the leading coefficient is positive, then the graph of this polynomial function falls to the left and rises to the right. Okay, if the degree of the polynomial function n is even, like 2, 4, 6, and the leading coefficient is less than 0, then the graph falls to the left and to the right. If the degree of the polynomial function is even, in like 2, 4, 6, but the coefficient, leading coefficient is an is greater than 0, then the graph of this polynomial function rises to the left and to the right. So here is example number 1. So we have a polynomial f of x equal to minus 2x to 7 minus 10x plus 8. So 7 is the degree, and the leading coefficient is the coefficient of this leading coefficient term, negative 2, and is less than 0. So the degree is odd, so the graph rises to the left and falls to the right. Okay, now here's example 2. We have a polynomial function 2x to 7 minus 10x plus 8. The degree is odd, but the leading coefficient is 2, which is positive. So the end behavior of this polynomial function would be it falls to the left and rises to the right. Example 3. So we have a polynomial function f of x equal to minus 3x to the 8 plus 9x cubed plus 12. The degree is 8, which is even, and minus 3 is the leading coefficient, which is less than 0. So the graph of this polynomial function falls to the left and to the right. Okay, example 4. We have f of x equal to 3x to the 8 plus 9x cubed plus 12. So the degree is 8 and is even. Leading coefficient is 3, which is positive. Then the graph of this polynomial function rises to the left and to the right. Next is zeros of polynomial functions. Zeros of polynomial function are the x values for which f of x is 0. So therefore, to find the zeros of the polynomial function, all we have to do is set f of x equal to 0 and then solve for x. So here's an example 5. Find the zeros of the polynomial function. So we have f of x equals 3 times x minus 5 squared times x plus 4. So this polynomial is in factored form. So we do not need to multiply to find the zeros. All we have to do is set this to 0. Now this is already factored, so we set each factor to 0. So 3 equals 0, but remember it's false, so we ignore that one. Now we set x minus 5 squared to 0, and if we take the square root, you just get x minus 5 equal to 0. Move the negative 5 to the right, and becomes x equal to 5. So you got 0. 5 is our 0. Then set x plus 4 equals 0, and then move 4 to the right, become negative 4. So we have x minus 4. So this is our next 0. Now we rewrite all the zeros. So that we have zeros are. So we write from smallest to largest, negative 4 and 5. Multiplicity of a zero of a polynomial function. If a polynomial function has a factor x minus 6 that appears exactly k time, then c is the zero of multiplicity k. Basically saying if you have a factor like this one, its power is k, then this c is a 0 and this multiplicity will be what? K. So here's an example. So we have f of x equal to x cubed times x minus 1 times x minus 3 squared times x plus 5 to the 9. So you can notice if I set x cubed to 0 and solve for x, I will get x equal to 0. Now 0 is coming from x cubed and its power is 3, so we can say 0 is a 0 of multiplicity 3. Now if I set x minus 1 to 0 and you get x equals to 1, so and the exponent of x minus 1 is 1, so we can say 1 is a 0 of multiplicity 1. Now x minus 3 squared. Now 3 is a 0, and since coming from this factor whose degree is 2, so we can say 3 is a 0 of multiplicity 2. Now from this factor, if I set this to 0, I will get x equal to negative 5. So the negative 5 coming from this factor whose degree is n9, so we will say negative 5 is a 0 of multiplicity 9. Number of turning points of a polynomial functions. So just looking at the degree of the polynomial, we can tell that how many turning points a graph of polynomial function will have. So the graph of polynomial function of degree n has at most n minus 1 turning point. So basically it's a maximum turning point. So you could have a less than that one, but not more than n minus 1. So here is an example. We have a polynomial f of x equals 7x to the 5 minus 5x cubed plus 4x. So if you graph this one, so without graphing we can tell how many maximal possible turning points. Well, degree is 5, so according to this, so the maximum possible number of turning points of the graph of this polynomial would be 5 minus 1 equals to 4. Finding the zeros. So we have a polynomial f of x equal to x to the 5 plus x cubed minus 12x. So first we're going to find all the real zeros, and then we're going to determine whether the multiplicity of each zero is even or odd. Then determine the maximum possible number of turning points of the graph, and then graph the function. Okay, so A part. To find the zeros of this polynomial, x to the 5 plus x cubed minus 12x, so we set this to 0. So you can see every term has a x, so we can factor x. So if you factor x, you get x to the 4 plus x squared minus 12. It looks like we can factor x to the 4 into x squared and x squared, and minus 12 into 4 times negative 3. So we have factors of this would be x times x squared plus 4 times x squared minus 3 equal to 0. So we have 3 factors. So we set each factor to 0. So if we set the first x equal to 0, and so this is our real 0. Now we set x squared plus 4 equal to 0. We we take the 4 to the right. So we have x squared minus 4, and then we take the square root. So we get x equal to plus and minus square root of negative 4. We cannot find the square root of negative 4. So these are not real numbers. So we ignored this one because we're looking for only real zeros. So now we set the next factor to 0, x squared minus 3 equal to 0. Take the minus 3 to the right, and you get x squared equals to 3. Now we take the square root of both sides. You will have x equal to plus minus square root of 3. So now we rewrite all the zeros in order. So the smallest is negative square root of 3. The next is 0. And the next is positive square root of 3. Multiplicity of 0 is 1. And this is odd. Multiplicity of negative square root of 3 is also 1, which is odd. So multiplicity of square root of 3 is 1, which is odd. So we have a polynomial f of x equals to x to the 5th power plus x cubed minus 12x. The degree is 5. So the maximum possible number of turning points of this, the graph of this is just 4. Now to graph this polynomial, so we TID 4, we can press y equals to and then type this expression and then press enter and then press on graph and then press on zoom and move the cursors to Z standard and press on that one and you will get this graph. So next is finding a polynomial. So we are given the zeros, that's the real zeros, C1, C2, C3, Cn. To find the polynomial next, we will do the following. First we subtract each zero from the axis. So become x minus C1, x minus C2, x minus C3, and x minus Cn. Then we multiply all this and set this equal to f of x. And then of course when we multiply, then we have to simplify. Example 8, finding a polynomial function. So we're going to find a polynomial function that has zeros, 0, 6, negative 5. So first we're going to do subtract these 0 from the axis. So you will have x minus 0, x minus 6, and x minus minus 5. Then we multiply and set this equals to f of x. So we have f of x equal to x times x minus 6 times x plus 5. So the negative 5 becomes plus 5. Now we just multiply from the left to right, so it looks like we can distribute x into x minus 6. So it becomes x squared minus 6x, and this right x plus 5. Now we have two binomials. We can multiply using repeating distribution. So we multiply x squared into x plus 5, and then minus 6x into x plus 5. So now we distribute x squared times x is x cubed, x squared times 5 is 5x squared. And the minus 6x times x is minus 6x squared, and the minus 6x times 5 is negative 30x. And now you can see these two terms have same exponent, so they are like terms. So we can combine. So we will have x cubed, and 5 minus 6 becomes negative x squared and minus 30x. So that's the polynomial obtained from these zeros. Intermediate value theorem. So let f be a polynomial function, and we have two numbers a is less than b, and we find f of a and then find f of b. And if they have opposite signs, then we'll say f has at least one zero on this interval ab. So example 9. So we have a polynomial f of x equal to x to the 4 plus 8x cubed minus 20x plus 12, and we want to determine if this has a 0 on the interval 1 to 2. So according to intermediate value theorem, we will find the function value at 1. So we have a f of x equal to x to the 4 plus 4x cubed minus 20x plus 12. So we substitute 1 with the x's, so become 1 to the 4 plus 4 times 1 cubed minus 20 times 1 plus 12. So 1 to the 4 is 1, and 4 times 1 cubed is 4, minus 20 plus 12, and you should get negative 3. And that's negative. Now we find the function value at 2, it becomes 2 to the 4 plus 4 times 2 cubed minus 20 times 2 plus 12. So if you simplify, we should get 20, and this is positive. So f of 1 is negative and f of 2 is positive. So that means f of 1 and f 2 have opposite signs. So therefore we can say this polynomial has a 0 on this interval.